We'll use the strategies we learned in the Introduction to Limits video of making a t-table and constructing an input sequence and seeing what happens to the output sequence to answer these. A couple things to remember. One, you'll notice that there's no plus or minus as in the exponents region of these numbers. So that means we have to check both the limit from the left and from the right on each of these in order to be able to answer the question, because we're being asked what is the limit as x approaches 2. And in order to answer that question, we have to check both what is the limit as x approaches 2 from the left and what is the limit as x approaches 2 from the right. And if they are equal, then we have an answer to the question that's here on the screen. If they are different, then we say that the limit doesn't exist, that there is no limit. Okay. So in order to do these problems a little more quickly and more efficiently, and to not have to do an evaluation of the function for each and every input variable, we're going to utilize the table feature in our TI-83 calculator. And if you have any of the other TI-83s or 84 series of calculators, this will look pretty much exactly the same. We'll use the table feature to let the calculator sort of do all of the tedious calculations for us so that we can get about to actually interpreting our results and determining whether or not we have a limit or for whatever reason we might need that. So there's a video below, or the video there on the screen that you can go ahead and click on and watch, or you can go directly to YouTube using that URL that's on the screen there, especially if you need captioning for the video. The video on YouTube will have closed captioning. So go ahead, grab your calculator, and have a sit down and watch the video that's there on the screen. Okay, so now that we've got our calculator set up to do what we need it to do, we're going to go ahead and do our first example here, which is the limit of x squared minus 5 as x approaches 2. Again, since there's no plus or minus up here, this implies that we must check both. The limit as x approaches 2 from the left of x squared minus 5. Let's see what that answer is. And we must also check the limit as x approaches 2 from the right of x squared minus 5. See what the outputs look like. So we're going to make a couple of tables here. So we're going to do as x approaches 2 from the left first. So again, if we kind of visualize, here's 2. 1 is to the left of 2, so I want to start with numbers that are to the left. So again, you don't have to pick the 1.9, 1.99. You can start at 1 and then do 1.5 and then 1.75 and then do 1.9 and 1.95 and 1.99 and 1.999 and eventually get to 1.9999, etc. Okay. So we're going to go ahead and I'm going to pause, or you should pause at this point, and go ahead and enter those x values into your calculator and then see what you get as the sequence of outputs, and we'll come back and share our results. Welcome back. So if you used those sequence of inputs, which approaches 2 from the left, well, notice that as we go down the sequence, so if we go down the sequence this way, our sequence of outputs, and we follow them down, we start out at -4 and then down to -2.75 and down, and it takes a little while for us to see what the pattern is, and that if we chose the next item in the sequence, if we did choose 1.99999, we'd have a better idea of what that answer would be. So if we take a look at the sequence of outputs, they are approaching -1, because as we go further, closer and closer to 2 from the left, we'll get a -1 followed by more and more zeros, so essentially approaching -1. So that's our answer to as x approaches 2 from the left. The answer is -1. So now let's go ahead and change our sequence, and we're going to clear out the left-hand column and the right-hand column, and now we're going to approach 2 from the right. So now if we're approaching 2 from the right, we're going to be starting basically to the right or closer to 3 and then moving toward 2. So again, whatever the sequence is, it just has to start on the right of 2 and slowly approach 2. Right, so we're going to create our sequence starting at 3, moving our way in. And let's see. So we want to maybe start at 2.5 and then get a little closer, 2.25, then 2.1, 2.01, 2.001, and then 2.0001. So let's go ahead and hit pause, and you're going to enter those into your table feature in your calculator and see what we get as results. Okay, so hopefully you finished your calculations and you got something very, very close to what we have here, as long as you used this sequence of inputs that approach 2 from the right, and we take a look at our sequence of outputs and what they approach. So if we examine, it's not quite clear with the first couple when we plug in 2.5 and 2.25 and 2.1, but as we get closer and closer to 2, it starts to become a little clear, right? We start to pile up more 9s at the front and the back there. So eventually we're going to have a series of 9s, 0.999999, etc., with a 5 and then lots more 9s. So we are approaching -1 from a slightly different way, but that's fine. We don't really care. We just want to know, is that sequence approaching a particular number? And the answer is yes, it is -1. And since these are the same, then that tells me that the answer to the limit as x approaches 2 of x squared minus 5 is that number, -1. Our next example has the limit as y approaches -2 of 3y over y plus 5. And now students sometimes have a little trouble here because, y we usually use it as the output, but we're using it as an input. But remember, a variable, all it is a placeholder. So if you don't like y as the placeholder, we can rewrite this as the limit as x approaches -2 of 3x over x plus 5. Now, when we use the table feature here and we use our graphing calculator, we do have to be a little bit careful. And when we enter this in your calculator, we want to make sure our calculator follows the correct order of operations that I want it to do here. So I am going to make sure that I enter this with parentheses around my denominator. So the calculator knows the whole quantity, x plus 5, is what gets divided into the 3x, right? So that whole quantity, x plus 5, is the divisor, the denominator, okay? So make sure when you do that. All right, so again, there's no plus or minus up here, so that implies we have to check both the limit as x approaches -2 from the left of 3x over x plus 5, and we have to check the limit as x approaches -2 from the right of 3x over x plus 5. And if they are the same, then we have an answer to that problem. All right, so let's make our table. So we've got x, and we've got 3x over x plus 5 as our output. And make my little number line here, because now I want to approach -2. So we have to be a little careful here because negatives are sort of the opposite of the positives, right? So everything is sort of flip-flopped. So now if I want to approach from the left and head toward -2, I'm starting at something like -2.5 and then -2.25, etc. So my table will look like the following. So make sure you go into the y equals screen, change your function so the calculator knows we're working with a new function, and then go ahead to the table and enter your inputs and see what the sequence of outputs looks like. Hit pause and I'll wait. Welcome back. And so hopefully you used your calculator and the table feature after changing the function to 3x over x plus 5. One thing I'm going to point out is I did add one more input because I wasn't quite sure that I was seeing the full trend in the sequence of outputs. Okay, so as we examine the sequence of inputs and they approach 2 from the left, I can see that my sequence of outputs, if I follow along here, they start at -3 and then get a little bit closer to -2 each time. So here, the output is -2. Oops, sorry. The inputs were approaching -2 from the left, not 2, but -2 from the left. Turns out the outputs are also approaching -2. So the limit as x approaches -2 from the left is -2. Okay, so now we're going to go ahead and replace our values where x approaches -2 from the left with values where x approaches -2 from the right. Okay, so my table for now when I'm approaching from the right, so from the right, I'm going to start at -1 and move in towards. So I might start at -1.5 and then -1.75, etc. So -1.5, -1.75, -1.9, -1.99, 1.999, let's do one more just for good measure. Okay, so again, you're going to go ahead and hit pause, and you're going to use that sequence of inputs in the table feature in your calculator, and then come back after you filled in the right-hand side of the table, and we'll compare our answers. Welcome back, and we're going to go ahead and check. So we've got our sequence of inputs that are approaching -2 this time from the right, and we check our sequence of outputs, and they seem to be approaching -2. Right? As we get farther down the list, I get 1 followed by even more and more 9s. So when I plug in -1.99, I get -1.983389. And then when I plug in -1.999, I get -1.99, so another 9. And notice we also pick up another 3, right? And then when I plug in -1 followed by 4 9s, I see an increase in the 9s and an increase in the 3s. So really the idea here is we want to focus on the fact that the leading part here, right, we're getting more and more 9s at the end. So it's getting closer to -1.9999, right, followed by lots and lots of 9s, which is pretty close to -2. The trend is toward -2. So the limit from the right is also -2. And since these are the same, that tells me that the answer here is that number, -2.